Okay, good morning class. So today we're looking at Euclidean geometry. In this video we're going to look probably at number 1, 2 and 3. I don't think we'll get even to 4. Okay, so this is number 1. Oh, I don't need to run. Okay. So here we are told in exercise, whoops. So here we are told that ABCD is a cyclic quadrilateral. People, if ABCD is a cyclic quadrilateral, what do we know? Many things is. But specifically we know that opposite angles are supplementary. We also know that the exterior angle, which is C3, is equal to the interior opposite angle. You see that, people? That is not an exterior angle. Why? Because that must be one of the lengths must be extended. As you can see here, it's extended. Okay. Then we are told that a tangent to the circle at D. People, if this is a tangent at D2, then what do we know? That D2 is equal to A2. Why? Tan-core theorem. Then we are told that AB is parallel. It doesn't sound like you guys did your homework, okay? AB is parallel to BCE. These lines are parallel, what do we know? Alternate angles are equal. So this angle is equal to that angle. That angle is equal to that whole angle there. These lines are parallel. So that angle is actually equal to that angle there as well. Alternate angles there. Then we are told that DC is drawn, C3 is 70. Write down, giving reasons, 3 other angles equal to 70. So here's 1. That was the exterior angle of cyclic quad, no? Where else? Sorry? D2Y. Sorry? No, that dot, A2 and D2 is here. Yes. There's your cyclic quad. This length is extended. So this angle is equal to that whole angle. Yes?
C1 and C1.
Sorry?
C1 and C1.
Because it's totally opposite. Remember, there's that one line and there's the other line. So that angle is equal to that angle. Last chance before I give you the answer. It's sad to see that you guys haven't done your homework. No?
So,
Yes?
C3 is equal to DAB, and then
Say again?
C3 is equal
Yeah.
to DAB.
D, A, B. Yes.
Yeah. And then
This was the 70 I was talking about.
then C1 is equal to
A2.
yeah.
Yeah? We're looking at 30. That's why I say it's sad that you guys haven't done your homework. Because I heard it says write down giving reasons 3 angles equal to 70. You don't even know what the question says. Yes? Okay, I'll tell you. C3 is also equal to D1. Why? Alternate angles. And then D1 is equal to C2. Angles opposite equal sides. Go. Okay, I see you guys need to prove yourself once you can do maths in the first term. After that, you just on pilot mode. No? By the looks of it. Right, so we're saying that a DAB is equal to 70. Exterior angle of cyclic quad. So I write 17 here now. Then I say that D1 is also equal to 70. Why? Alternate angles with BE being parallel to AD. So 70. Then we said C2 is also 70. Why? Angles opposite equal sides. That's something like 6 marks. Okay. Let's look at the next question. Just trying to give the what's the name in focus here, the diagram in focus. It says calculate C1. So I'm going to calculate C1. Angles on a straight line. So angle C1 plus 2 times 70 is equal to 180. Straight line. So angle C1 is equal to is 140, gives you an angle of 40 degrees. Okay. C. C1. We just did C1. They asked it to you twice. Oh, now you're giving reasons to how the angles equal to C1. So in other words, you must calculate which angles is 40. Not so. So which other angle is 40? A1. A2 is 40. So A2 is 40. Why? It's alternate angles with BC being parallel to AD. And then D2 is 40. Why? Tan 40. Okay. You will enjoy the rest of your day, the weekend. Please conclude exercise 9.7. Please, people. So we will just merge the other video from numbers 2, 3 and 4 on Monday. Okay, good morning class. So today we're looking at Euclidean Geometry. We're actually doing the exercises, okay. Okay, so in our last lesson we did number 1, not some of this exercise. So the idea is to do at least 4 sums per video, okay. So that video is not too short or not too long, okay. So at this point we are doing number 2, okay. Did you complete number 1? Yes. So we're looking at number 2. So here we are told that M is the midpoint of chord TP. People, if M is the midpoint of the chord TP, what do we know? We know that M4 is equal to 90 degrees, as well as M3, M2 and M1. Why? Bisector from center is perpendicular to chord. Then we are told that OR is the radius, okay, drawn through M, cutting the circle at R. PR is produced to intersect. PR is produced, which means to say extended to cut. This is now a tangent at A. People, if this is a tangent, what do we know? That T2 is equal to? Is equal to P. Why? Tan theorem. Then we are told that such that TA is perpendicular to P, to TA is perpendicular to PA. Okay? So remember, that's also 90. So what does that mean? That MRAT is a cyclic chord. Why? Exterior angle is equal to the interior opposite. Yes, Michael?
So M4 is equal to angle A. They add up to something.
M4 is equal to angle A. That's also fine. Why? Opposite angles of cyclic chord is supplementary. Nice. Right, first question. Prove that MRAT is a cyclic chord. We just went through that now. Not so. I'm going to pull that up. Question says prove that. So we're going to firstly say that M4 is equal to 90 degrees. Why? Bisector from center to chord. From center to chord is perpendicular to. Okay. So now, as the Bailey said, since M4 plus angle A is equal to 180 degrees, so therefore MRAT is a cyclic chord. Why? Because opposite angles are supplementary. Okay. If they ask you to prove something is a cyclic chord, okay, you can't use cyclic chord in its reason unless you say converse of opposite angles of a cyclic chord, okay, which is the reverse. Otherwise, you would just say opposite angle supplementary, which is the proper wording here. Okay. So, any confusion there, people? No. Then they ask you. So that means to say that all cyclic quadrilateral properties are now evident in that diagram. Okay, I can almost draw. I can draw a circle through that now. Okay, but I'm not going to because I don't want to mess the diagram up too much. Okay, let's look at B. So B says prove that TR is equal to RP. Alright. So how are we going to prove that TR is equal to TP? We're going to there's no real okay, before we go into that, if TR is equal to TP, then T1 would have been equal to P. If I can prove that, the job is done. But from the information that I got, there's no way I can do that. Okay? So that's not going to work for us at this point. However, what I've noticed is that I know that this is going to be 90 and 90. This is a common, and those lengths are equal. So how am I going to prove that those lengths are equal? I'm going to prove that triangle TMR is congruent to PMR. Okay. Then in turn, the corresponding sides will be equal. Okay. So where do we start? We say in triangle. Whenever we do congruency or similarity, we name the triangles. So you say in triangle, TMR and triangle, so it's TMR and PMR. So what do I say? I can say that M3 is equal to 90 degrees. Why? Straight line, angles on a straight line. Okay, then we know that MR, this line here, is a common side. It's either common side or a common angle. In this case, it's a common angle. Then TM is equal to MR. MP, sorry. Why? Is given this. So therefore, triangle TMR is congruent to triangle PMR. Why? Because side, angle, side. But you're going to say, but we're using 90 degrees here. So you must use RHS. But have you used the hypotenuse here? No. That is why it's side, angle, side. Okay. So therefore, from here we can conclude that TM is equal to MP. So TM is equal, but we knew that. MR is equal to MR. That's your common side. And TR, of course, equal to PR. And that's what they wanted from us. You guys see that? So we say therefore TR is equal to PR. Why? Because triangle TMR is congruent to triangle PMR. Okay? And then I make that marking here as well. Why do I do that marking on the diagram? So at one glance at the diagram, I know exactly what we have. Okay. Take this off again. And then the space. C. C says prove that T1 is equal to T2. So what I do is I let T1 equal to X or T2 whatever. But this one is fairly simple, so I didn't even have to do it, okay? So we know that T2 is equal to P. Why? Tan chord theorem. And then angle P is equal to T1. Why? Angles opposite equal sides. And therefore T1 is equal to T2. Okay. But if you're that kind of girl that always want to bring in your X, so we say that angle T2 equal X. Then angle T2 equal X. So then angle P is equal to X. Why? Tan chord theorem as we said. And then T1 is equal to X. As angles opposite equal sides. And therefore, T1 is equal to T2, which is equal to X. Okay. Any confusion? It's fairly simple. No? Look at number 3. Okay, so number 3 we are told, given a radii OP and OM. So OP and OM. People with that knowing that is your radii, what do we know? We know that P2 is equal to A2. Okay? Also, if this is the center, we know that O1 is double angle Q. Okay? Angular center is first angular circumference. Then we are told that both MP and QM and QP are drawn. MN is a tangent. People, if this is a tangent, what do we know? We know that M1 is equal to angle Q. Why? Tan chord theorem. Okay, remember this is a tangent. Also, this is your radii here. So this angle is going to be 90 degrees. Why? Radius perpendicular to tangent. Okay. Then we are told that Pn is equal to Pm. Pn is equal to, if that's the case, what do we know? M1 is equal to 25. Why? Angles opposite equal sides, as those lengths are equal. Calculate the size of the following given the reasons. Okay. So, what we do is we're going to take this off, so we don't tend to leave anything out when we're doing the proof or the calculation itself. Okay. So first things first. They ask you to work out angle Q. So we said that first thing, M1 is equal to 25 degrees. So M1 is equal to 25 degrees. Why? Angles opposite equal sides. Okay. Then M1 is equal to Q. The angle Q is 25. Why? Tan chord theorem. Okay. And then we answer the question. B. M2. Okay. So M2 is basically this angle here. Not so. But we already said that this angle stands 90 degrees to the tangent here. Not so. The radius and the tangent there. So M2 is equal to 90 minus 25 degrees. Why? The radius perpendicular to tangent. So M2 works out to be 65. Is that correct? Is there a C to this question? You know asked to calculate O1 or anything else? Huh? Yes? 3A.
Yes, for 3A can you use interior angles?
So you also get 25 here. Yeah? But you went a longer way around. Yeah. Number 4. So in number 4 we are told that M is the center of the circle and MBCD. MBCD is a parallelogram. People, if that's a parallelogram, what do we know? Opposite angles are equal. The angles bisect each other. Opposite lines are parallel. One more. Opposite sides are equal. Okay, two pairs of opposite sides are equal. So we are told that M is the center, center of the circle. So if M is the center of the circle, what do we know? That M1 is equal to twice angle A. Why? Angle at center is twice angle at circumference. Okay. Then we are told that ABD are drawn. D2 is 30. So D2 is 30 degrees. 30 goes here. Alright, the question says, list giving reasons 3 other angles that's equal to 30. 3 other angles equal to 30? Sorry? B2 is 31. B2 is equal to 30 degrees. Those lengths are equal, not so. So you say angles, opposite, equal sides, and it's your radius. Not so. And then B3 is 31. Alternate angles. Not so. B3 is 30, alternate angles. Alternate angles with MB being parallel to CC. BC. So it is going this way. So it's MD. Okay. And then D3 is also 31. The alternate going that way now. Not so. So D3 is 30 degrees. Again is alternate angles with MB is parallel to BC. Okay, so there we got 3 other angles equal to 30. Then the B part of the question says, calculate giving reasons the size of M1. So what I'm going to do is I'm going to pull that up. Take this off. Oops. B1, M1. That is simple. This is sum of triangles here, not so. Okay. So M1 is equal to 180 minus 2 times 30. Sum of triangles, that is triangle DMB. Okay, which gives you 120. Okay. You all agree with that?
Yes.
Then we go angle at center, which twice angle at circumference. You see that? So angle A is equal to half times 120, or just 60. Why? Angle at center is equal to 2 times angle at circumference. Okay, which gives you an angle of 60 degrees. Any confusion there? Alright.
So
Yes?
what I did, I first calculated C and then I said A1 is equal to C.
Sorry?
What I did so was
First calculated
C.
C. How do you calculate C?
Same equals A1. And then I said
Now why is C equal to 120?
opposite angles equal parallel.
Nice, well done. So you're saying that C is 120, opposite angles of parallelogram, or you could have gone sum of angles in the quad. So you got 120, and then you can say the opposite angles are supplementary in a cycle. Nice, well done. Anybody else? Full marks you'll get for that as well. Okay. C. There's two parts to C. So now with this in mind, and of course we're going to keep this, we'll keep the diagram in focus, so we need to take this off. But whatever we've calculated is already on the diagram. Okay. You don't erase yours in your exam. Okay. The question says calculate giving a reason the size of angle C. Using the properties of quadrilaterals. So angle C is simply 120. Why? Opposite angles of parallelogram are equal. Okay, so C is 120. Using properties of a quadrilateral.
So
Yes?
it's 60 because we're supposed to use A plus C.
It says here, using properties of quadrilateral. Oh, sorry, I'm using it wrong. They say calculate with reason angle C using properties of quadrilateral ABC. I'm thinking parallelogram. So it's A, B, C, D. Have I calculated angle A already? Yes, angle A is 60. This answer that I got here is actually that answer. That's using properties of a quadrilateral M, B, C, D. That is opposite angles of a parallelogram Z. So I'm coming back to A, the first one. This is this quad they are referring to here. Okay. So now we know that angle C plus 60 degrees equals 180. Why? Opposite angles of cyclic quad is supplementary. So anyway, angle C works out to be 120 degrees. Okay, you guys understand? Is there any confusion there? Alright. So with that, it brings us